Hey, what's up, students? I want to go over the Karmel Cone really quick. So I'm not giving you the exact one from the checkpoint, but I'm going to give you the ideas of it. Basically, what we have here is we have a negative number and a variable, a negative monomial. That's a word you're going to learn in the not too distant future. And then we're taking it to even and odd powers, both positive and negative. So basically, if you follow these rules, you're going to be okay. Remember your frying pan rules. Everything on the inside is going to get sprinkled with the frying pan, or sprinkle with the seasoning, or you can just simply write out what it means. Negative 3x to the third power means you have three of these being multiplied. People sometimes get confused on if the answer is going to be positive or negative. Well, the reason a negative number to the odd is going to stay negative is because there's always going to be one negative left over to keep it negative. These two negatives will cancel, but this negative will keep it negative. So basically, it's 3 times 3 times 3 with one negative in there. So it's going to be a negative 27. And then x is going to be x to the third power. I don't like that. Let's make it a power. There we go. All right. So this will stay negative. Now, basically, from there, you can kind of start boiling it down to the next move. The next move, it's going to be, I copied more than I wanted to. The next one is going to be negative 3x squared. So that's negative 3x times itself, times negative 3x. That's why anything to an even exponent, any negative, excuse me, not anything, any negative number in brackets to an even exponent is going to become positive. The negative is going to cancel because you have two of them. It takes groups of two negatives to cancel. So if we have two of them, they're going to cancel. So 3 times 3 is 9, and that would be x to the second power. All right. Excuse me. As you can see, I've already dealt with the negative exponent, so the rules don't change. If the exponents are negative, that has absolutely no play on if the answer is negative or not. Because here we had a positive exponent, and we had a positive answer. Here we had another positive exponent, but then we had a negative. Okay, it has to do with even and oddness on if it's going to be positive or negative. So also remember your negative rules. Negative 1 is going to flip this. This negative 3x does not want to be above the fraction bar. It wants to be below the fraction bar. So a negative 3x to the negative first power is just going to become a 1 over a negative 3x, which if you were to write it simply, if you were to simplify it, the negative would move all the way to the front. That is the best way to write negative fractions. If the denominator is negative, you better move that negative out front. All right, so this one's going to take a little bit of time here. So you can follow your frying pan rules. You can stick this negative 2 to each item, or you can rewrite it on what it is. I'm going to copy and paste this really quick because I need this, okay? And then I'm also going to move the negative down here because I got to rewrite what it is. So if I go like this, I got to make a group bracket right there and a bracket right there. Oops, that's the wrong bracket. And then a power of 2. Where is the power button? There it is. And I need to put 2 right there. And then I want this to go away. It's not going to make it go away. All right, we're just going to do that. All right. The formatting is not being friendly with me. Okay, so here's what the negative 2 does. The negative 2 says, hey, this negative 3x doesn't want to be above the fraction bar, so you move it down below. So basically what you have here, students, is you have 1 over the same thing you had right here. So this is now down here. So if you were going to rewrite it down here, I wonder if it'll let me do this. I hope it does. Let's see what happens here. All right, look at that. Sweet, that worked. Okay, that's basically what's going on here. Okay, this negative 2 moves these two down to the bottom, and then it's the same thing that it would be right there. So if you copy and paste, the negatives completely cancel. If I can select the right piece of it. Nope, just that much. One more piece. There we go. All right, there you go. 1 over 9x squared. So as you can see, negative 3x squared and negative 3x to the negative second, or negative square, they have the same basically answer. Just one is flipped and one stays above the fraction bar. So go through and take your time. It's basically a combination of negatives and positives and understanding when they stay positive and when they stay negative with odds and evens. But if you follow these rules, then you really can't mess this one up. I do believe it's matching and multiple choice. I'm not going to make you type all these out. So just take your time with that one and everything will be okay. That's the Karmel Cone.